Hi, everyone, and welcome to this week's episode of The Context. We have a great show today. Liran Tal from Snyk is here with us to talk about MCP security, and it should be a great discussion. Really, this whole podcast / live stream came about because we first ran the first MCP Dev Summit, and we had so many great talks submitted that we couldn't fit them all in, and so we're gonna keep doing the same thing and keep publishing talks when people have things they want to comment on in the space. So obviously we're all on the same YouTube channel between us and the summit. So feel free to submit your talks. You can scan the QR code on the screen right now. And we've got some good ones coming up, and I'm very excited for today's talk. So we have Liran joining us from Tel Aviv. Liran, thanks for staying up into the evening and dedicating your evening to sharing with us a little bit about putting the S in MCP, or what the S that doesn't exist in MCP.
Yeah, it's a great, Errol. Thank you. My pleasure. It's so much fun being here.
Awesome. Well, the floor is yours, my friend. Take it away.
All right, amazing. Please do ask questions or comment. If you're watching this live, would love to go through that. So I'll start with slides. I think we'll kind of get the demos and everything ready. And yeah, I'd love to demo some more stuff live. So just set a stage and show what's going on. I like how you also used the balancing part. So I feel that's a very important aspect of this talk. I'm hopeful that you'll kind of get some responsible kind of mindset when you use MCPs from this point on. So hopefully I'll be flagging some stuff for you. So I've actually used that. The SNMCP stands for security a while back. That's from the first time I've actually put it out was at that moment, so many, this was early on, and so many things were just chaotic, as it kind of makes sense. So I'm happy things have evolved for MCP. But I'll try to show today what hasn't, and all the kind of stuff that you should look at. So I'm a big fan of MCP. I've actually built some tools around it, try to figure out some MCP best practices stuff for it. I've also from my security AI security researcher hat kind of found a lot of vulnerabilities in different kind of MCP servers. Some from Astra, which are really great people, and I love that framework from Apache Doris as well, from the Apache project. So there's a bunch of vulnerabilities in open source MCP server code, some of which actually predates mine as well, they were disclosed through Anthropic and others. So we'll talk about some of them here. But just to tell you that this is a lot of that is still an ongoing effort. Other than that, I've been doing a lot of other things around security, Node.js, and open source in general, and kind of doing this, speaking and educating devs. I hopeful try to be at Snyk. So I will speed run through this. We don't need the MCP 101 because you're all here, you know this. So I'll go ahead and speed pass it. There we go. We have it so far. Yes, great. So this I want to show you though, and I'm going to talk about commands and SCDI kind of MCP server, because that's an easy one. So when you see this, when you see this JSON for an MCP server configuration, I think a lot of the people are yeah, that's so cool with MCPs. They're easy to install, easy to publish, cool stuff. We can just push it into the npm or the PyPI registry, which is great and it's good. At the same time, well, attackers and adversarials kind of think the same thing. It is easy to install for developers. Okay, maybe that is something I kind of want to target. It's easy to publish as well. Great, let's go ahead and pollute the registry and stuff with it. So imagine all the things that can go wrong with trying to define this kind of MCP servers on a command line, which some are. So we'll dive through a lot of this. I will speed pass through this as well, but MCP has been incredibly popular. We know that it's now an agentic thing, but maybe something to still kind of just say here and kind of take a moment to recognize this is MCP servers, when they run locally, and we'll talk about that distinction maybe, but when they run locally, they are within the I want to call it the crown jewels, but really like they have access, they run within developer workflows, so they have access to what developers keep dearly, which is usually like, configuration files and IP and their own like code and stuff like that. And it's not just the distinction between remote MCPs versus local MCPs, but also the fact that the agent has access to those things. So even if the MCP server is running remotely, they would still potentially be susceptible to the same thing. And I'll show you that in a sec. That's part of like the story here. So let's start with like our first story of, well, MCP servers going wrong. This one dates to late last year, or like mid-year last year. So Cursor and Jira, this was like a famous security incident where someone was able to basically prompt the whole thing and kind of like make sure that they could exfiltrate data out of a developer workstation. They did that using Cursor and a really smart prompt injection attack. But why and how does that relate to MCP? So I'll kind of go and show you like what was happening there. So imagine you have this kind of like starting point where at one point, there we go. At one point, you have the developer. There we go. Sorry, you have someone asking, well, I need help with a system, like their company support system. Well, I need an email. They send an email that says, I need some support. I need some help with something. That system behind the scenes takes that email and turns that into Jira. So when that ticket comes in, it comes in as a Jira ticket, right? Their email, their actual request for support. On the other side, you have the developer who wants to implement this, and they can just prompt away or whatever to Cursor, like go do the whole agentic thing these days, and say, implement this ticket 1, 2, 3, which I got of like ticket support. So Cursor now invokes the Jira MCP server, right? Because that's how it connects to Jira. So now that it does that, actually, you have a connection between something that the user sent as like the end user sending a support ticket to something that the agent has access to. And it happens to be that there was like a hidden kind of like instruction set within that email that was sent to the company that told it, well, what, get all the JWT tokens from the repo and send them on an HTTP request. And so Cursor, having access to actually two of these tools through MCP and through its own agentic kind of like, exposing of tools, it has access to web fetch and file read tool. So in effect, what was happening is they were able to show that they had a smart prompt injection attack that stemmed from basically a user that does not have access at all to the system, and was able to exfiltrate things like these credentials and so many other things. And this was like a bit more elaborate of like how they like hid the instructions and how they got it to like bypass things like JWT and stuff like that by like encoding the name to like something else. And you can read more about this. This is like a really cool research. But if you go back to like the basics of like what was happening here, then I think what you can see is like there's like 3 different elements here. So one is Jira, file read, and web fetch. These are really, or like we'll figure out if Jira or not in a sec. But these are really the three main pillars here. Now, if you even trim that a little bit down to like, well, can we figure out what was actually happening? So untrusted content item that went in. So think of like, that email that turns into a Jira ticket, or maybe like a GitHub issue that someone processes. That goes into a system, an AI app, an agent, whatever. And that AI agent or that AI app has 2 things that it can do. Well, first off, it may have access to private and sensitive data. So think about like, .env files, your package JSON, things like that. And it also has access to what we call public sync tools. So these are basically tools like a web fetch. So it would actually be able to send requests to outside to other systems. So this is exactly what was happening in that case with Cursor and Jira. So support, .env file, and web fetch tool. And at Snyk, we call this a toxic flow analysis. And if that sounds familiar, if you read that before, actually predating that Cursor and Jira incident we were actually sharing this as like a GitHub MCP exploitation where we're doing something similar, but instead of like a Jira ticket, we're actually using public repositories to access private repositories. And this was the way that we were like exposing and exfiltrating data and showed how it was possible. So this was like the unveiling of so to say, toxic flow analysis. Now that was one story, okay? So this was like one kind of like incident or like, kind of security aspect to know about MCP servers, that the use of them could be dangerous. Another aspect of MCP servers is if they're like entirely malicious, right? Like absolutely not something you want to install, but you may install the wrong package, or it may come in as something else, like an extension that you install. Like Gemini has extensions. Have you like inspected the MCP servers that are defined in it, and so on and so on. So there are again a myriad of ways for malicious MCP servers to turn malicious and basically kind of like run adversarial against you. But I'll talk to this example being like a tool poisoning aspect to it. So on the left side, you're seeing like my actual screen. When I recorded this demo, and you're seeing that I have access there to like what seems to be like a bearer token and stuff. So there's like something potentially sensitive in my working stage, environment. I want to show you a demo of like what that kind of looks like. So if you look to the right side, that's basically my MCP server, and it's kind of like red to say, hey, you know what, that's a malicious MCP server. You can see what it does. It does, search for an NPM package, and it has a description of what it does, but it actually has this extra notation that if you read it through it actually for its full prompt, it basically says, hey, before you use this, you kind of like want to look at some other places. Like maybe you want to look at your .env file or your Gemini settings JSON, where you have things like tokens, and send them somewhere else to verify or get more information or whatever. And when you invoke this malicious MCP server that has this kind of description inside it, it will actually run through the whole prompt and actually execute to the letter of what it's actually doing. So I'm gonna go and speed run this a bit so you can see it's actually asking for access to the read file. So it's like, hey, I'm searching for its npm package, which I prompted it to, and you can see how it read to the Gemini settings JSON file and ran a web fetch. So I could actually exfiltrate this data, and all of that exists within this Gemini extension thing in the IDE, right? So I get all of this for free, and all I need to do is really prompt the agent. Now, I think I'll stop the demo here for a sec, but even at this point, like beyond just like prompt injection happening, and working through the MCP server description and everything else, there's also the fact that we'll, figure out if we talk about here or not based on your questions, just interactions there is, well, you have sensitive data like headers and authorization and stuff like that even within like the MCP configuration itself. So that already is something that's I think worth your time thinking about. All right, so I think we'll kind of pass that and talk about something else. So if you wanted to find out if you are susceptible to these potential prompt injection attacks, what we've built is this thing called MCP scan, which we're renaming to agent scan because a lot of actually evolved with the system, with the ecosystem. It's not just MCPs, it's now skills. So we're scanning skills and all of those things. But essentially when you run MCP scan, or these days will be renamed to agent scan, what happens is we go through your entire system, where we go through like things like Cursor MCP JSON, like here, your Gemini settings, your VS Code, like all the popular or like the common top whatever agentic IDEs and tools, and we'll kind of like enumerate their MCP servers. And once we get that, even if something is like a local server or a remote server, we'll still try to connect to it. We'll get its tools and like description information, and we'll figure out if through our system, if that is something that would potentially be malicious or leak something, or even more so would be a toxic flow analysis. So with toxic flow analysis, the existing of maybe you have this tool that's like npm package search like I was showing, or potentially something like GitHub, the GitHub MCP server, that by itself might actually be enough to have a toxic flow analysis, just because like those two actually have maybe a lot of information within them that would ensure exfiltration. So how about another aspect of MCP servers? And I think that's kind of concluding a lot of it. But the idea so far is like, I'm trying to show you several ways of how MCP server security could go wrong, with whether toxic flow analysis, whether it's malicious MCP servers. This one is actually like very dear to my heart because it goes back to the basics of like secure coding conventions for MCP servers. So here's the idea, right? Like MCP servers are not really unicorn. They are just code that may have bugs, and sometimes those bugs are security bugs. So here's the example. Imagine I have this MCP server that gives you information about package statistics, or like you just want metadata about a package and so on. And you go ahead and install it, right? And it's showing here that I have no /tmp high file on disk. And I'm using it, and maybe I'm now like trying to do a prompt to the agent to ask it, hey, you know what? I want to use this library called React. Can you find it and get the information for it for me? And deliberately, what I'm doing is I'm actually using a payload here, React, semicolon ./temp/high to show that, well, if that's a potential like malicious payload that happens, then what's actually happening behind the scenes? So I'm going to run this. I'm basically asking Cursor to just use this MCP. It will hopefully figure out that it needs to use this MCP server that I installed. That gives you information about this npm package. And once I do, it will of course ask me, hey, do you want to run this? Maybe I say yes. Maybe I'm like YOLO. Maybe I'm like dangerously skip permissions to it. And it will go ahead and run it. It's kind of interesting to see that the attack succeeded. Like, we just created an empty file on disk. We could have done a lot more, like, exfiltrate the environment variables and send them and whatnot. But at the same time, like, you could see that on the right here, like, however, the name you provided looks like unusual, potentially a command injection. So even though the model kind of like had the reasoning afterwards, like post the attack happening, to understand that sometimes it's already too late. And I somewhat invite you to like try those kind of things in your code and your apps and your agents to see if that actually works, because these days there are a lot more mechanisms to protect against this. But this is just one example of command injection, which I've like reported several vulnerabilities of. So very, very real. And so I imagine everyone will just like ask me, okay, Liran, but like how real is this? Like, it's like command injection, like who works like that? Or like, professional engineers and agents write code, and like LLMs or like, models are like so, well, I don't know, advanced today, or like, have been definitely like getting a lot of training to produce more secure code. Maybe, maybe not, maybe a different question. So I think it is like a month or so after I've like recorded that video, maybe, that I got this great news, I guess. I don't know. So with Figma MCP server, and I'm sure that's like a great company, but they were exploited through this MCP server, which had a vulnerability in it. So how does that actually work? Actually, very, very simple. Like, it's kind of like what I showed you. There's an MCP server. Someone uses it, like a user, a developer, and attackers might send prompts, some kind of data, and within the workflow of what the agent will run. So specifically for Figma, they had this like download Figma images tool, and the way that it was implemented was not very secure. So you could see here, this is like from like the actual code. It actually sent like a curl command. So kind of like what I would do with that MCP server that I was just showing you to get like npm package information, where that I implemented that as a vulnerable demonstration was like just like exec, like system shell to npm, the command line, view, which is a subcommand that it gets, and then the package itself. So essentially this download images for Figma does the same thing using curl, not using correct or like secure coding conventions, and allowing input to flow in and change the way that the command is actually getting evaluated afterwards. So kind of real, I guess. I hope there's not a lot of it out there, but I have been disclosing several of these in the ecosystem. I'll talk through maybe if you want afterwards, like how we secure it, but basically there are different ways for if you look at things like securing code of like your tool implementation, resource implementation, and stuff like that. We are actually having this like this is SAST. So this is like just secure coding convention that we run a scan on your code, very deterministic. This is not like some AI slop thing that goes and like, does LLM stuff. It's actually very deterministic based on our engine, and it goes and checks all of those kind of sync to source to sync potential vulnerabilities that you may have in the code itself. So this is unrelated to like malicious prompt and stuff like that. That is agent scan or MCP scan, and this is something else. This is our like core product. You can see an example of this here. I have like an actual demo if we have time to like show afterwards as well. Or if you just use it in the IDE, just install it as a plugin, it will go ahead and show you things like, hey, I just discovered you have maybe like a path traversal here, and you can see that this is a resource of an MCP server that exposes some data, but potentially someone could abuse it. And we'll actually show you examples of how you fix it. So here's an example of how a correct code would look like. This is the part where we actually use generative AI to show you examples of code fixes and fix them and automate this whole thing, and so on and so forth. So there are like several different kind of like attack vectors or like landscape areas for you to like focus on. And these are the ways that we do it to fix it and save you from those issues. So I don't know, hopefully we got some questions, and I'm happy to like show some demos as well.
Yeah, thanks, Liran. That's exciting stuff. So I have my first question for you is really more about like, where you think we are right now. I think we've been, MCP is now kind of sitting around 18 months, not quite yet, but we're kind of coming up on 18 months since it first came out there. And it feels like there was a lot of really questionable MCP development sort of in the first 6 months, 8 months. It feels like things have kind of improved, and people are already, they're doing a lot more security around their MCP. So what's your take on kind of how the threats have evolved, or how common they are now versus, a few months ago or maybe a year ago?
Yeah, so I think a lot of it is still in place. I think what has been attempted to be solved for a long time has been that auth part of it. So the authentication and figuring out how that works with the spec and everything else. And I was like thinking, hey, if you want to make this interactive, like, could you want to put some security concerns here and so on? But to your question, I think if you want to deep dive into it, I've mapped this. This is like a sort of like, a framework that I work with. So to me, I split it into 4 ways. There's like the way to use build secure MCP servers, and that's at the end of the day now depends on developers or agents. You have the malicious MCP servers, which will always exist here as a potential issue, the way that you consume MCP servers, and the way that agentic MCP servers work. So if you even make like a bit of a deep dive into some of it, like for example, consuming MCP servers, yeah, like maybe auth and stuff like we figured out. But if you still have those kind of like settings JSON with MCP servers having their GitHub bearer token and stuff like that, I don't think that's a solved issue yet. Like the way that like you have still like have creds on disk. The fact that if if you're using specifically like about local MCP servers like stdio, you may have like things where you do like npx and then some MCP server, right? And that always gets the latest version, right? There's like no pinning. There's no like it's just not in the nature of like the way that has evolved. So you have those kind of issues. With agent, you have those indirect prompt injection still very much active, and toxic flow analysis is a real problem. And goes back into those things like you have vulnerable MCP server code, like I was showing with a command injection and path traversal, and SSRF. There's like I've found like SQL injections in a bunch of others as well. So I think those are kind of the things that are outside the like some of them, right? Like I think auth is kind of like getting a good effort from the team, from like the spec team. But there's like a lot of tangible kind of like security aspects that are like very supply chain in their nature to an extent that are not top of mind. And I mean, that's just choose MCP servers. It's like no one even thinks about, I think, any of those issues.
Do you think like, I mean, in a lot of ways, it feels like MCP security is not that different than package security. Like, it's like
I agree.
We've been dealing with this sort of same problem for a long time. And I kind of feel like the people who are getting hit with MCP vulnerabilities are really immature in their adoption of technology. You know what I mean? Like, I don't hear when I talk to a lot of more, kind of traditional organizations and people who are, kind of already running a relatively secure approach to IT consumption.
Yeah.
A lot of horror stories where they've been exploited or they've seen problems or there's been, exposure of data or like, it tends to be a lot more on the individual. Like at least the examples I've seen have tended to be a lot more on the individual. Do you agree with that? Or would you say, no, people have been hit. We hear about it. We're a security company, so we hear about it more than you do. And it's a lot bigger of a problem than maybe it feels like to someone who's, kind of maybe talking on the adoption side and talking to people building agents and talking to people consuming MCPs for their organization. I'm not saying they're not security conscious. They are. They just don't seem to be like seeing this like huge risk, materializing because they just immediately said like, okay, these are approved MCPs. These are the things we want using. Here's the ones that are built by us or our partners, and that's what you want to use. So, what's your take on what the real? I mean, you guys are, a huge security company. You must be talking to a lot of people about this. What's your take?
Yeah, no, I think that so confidence and like how much devs, like engineers and security people within organizations, I think they're like much more conscious to the problem. Probably like I like the analogy you made to like just regular supply chain security because they've seen that happening a lot. Like they've seen, typo squatting and malicious, packages and NPM and PyPy and all of those things. And I think that kind of like educated people to an extent, like a good extent. So like they're like now much more conscious on MCP. I feel a lot of the discussion is still like authentication, authorization, like all that is like more top of mind. Like see that the tool, like the agent through the MCP has access to the right data and they can access the other tenant or whatever, which is totally fair. That's like a very big aspect of like information security. But we are like, I think a lot of people like, if you ask enterprises, they really want to have like a good kind of like, enforcement and policy. So they don't want everyone to just install their own MCP server. Like if you like, go to like the CISO or like the security engineers within the company, like a big company, like not a 10 people startup, they would go crazy. Like, I have no idea what MCP servers my devs are using, right? Like, because it's so easy to add, people just like run so fast. So a lot of that is even like discovery and inventory. And I want to say I'm pretty confident, I think, that like the top popular, MCP servers from like, like say GitHub and Vercel and Cloudflare are probably well, built and all of that stuff. So it's a trusted upstream source to get MCP servers from. But if you think about it, truly like 6 months ago, 8 months ago, this was like very early on. And you know how we had like this whole saga with like Claude code, like OpenClaw skills, like going like amok and like a ton of them and like a bunch of them are malicious. It was the same with MCP. Like you had like MCP servers in like different hubs and marketplaces, like 5,000 of them. And do you know what you're using? People just like find something, they see big downloads, they use it, they download, they have no idea if it's malicious, if it's vulnerable. Like I think of like personally like disclose like 10 different kind of like vulnerabilities to MCP servers. Some, like I said, like very popular. But at that point, like that's just like sporadic me, looking for it. It's not even systematic. So
sure.
I feel to an extent this is a real problem, but also I kind of want to recognize that like MCP is one aspect for agents, and like there's a lot of there's like a balance between skills and MCPs and rules and commands. There's like a bunch of stuff that engineers and security people like have on their mind, and they're not really sure how to navigate that a lot of the time.
It's interesting because as somebody who does, is using more vibe coding to build apps and is often building apps with MCPs, at least in part of them, or as sort of a potential integration point. I've noticed that the MCPs, like Cloud Code or Open Code, things like that, are very good at analyzing the MCP. So one of the more common steps in a, vibe coding process is a security review, where you're like, okay, go review my entire system and make sure everything is, identify risks, identify vulnerabilities. I'm curious from your perspective, as a company that builds all these tools that, are using AI now to solve some of these same things. How do you perceive the potential of the agents themselves, the coding agents, as becoming more and more the dominant coder for a lot of development, but then also becoming in a lot of cases the first line of defense, in sense of they write the code and now they're asked to review the code, and it's literally the same thing. So on one hand, I'm like, it does find security vulnerabilities. I'm shocked how often on any project I was like, okay, go review everything from a security perspective, and it'll come back with 20 or 30 security recommendations to improve, and will improve its own code from, looking at it from a security angle. But also it does feel like a little bit the fox guarding the hen house, right? You're basically relying on the same model in many cases to review the code that it wrote under your guidance. So I'm just, it's an interesting time, because the security tools themselves are becoming, like you show, they're adding AI functionality to them. Yeah. But I'm less inclined to go add a new piece of code or a scanning tool, because the AI also is offering it also is doing a lot of that same scanning and looking for the same patterns and heuristics that we would have usually looked for a scanning tool to do. So what's your take on kind of, maybe this is a broader question, but why should we even use scanning tools? Why not just is the argument that you don't want to trust the same thing that's coding, or what's the argument for this? I mean, the latest vulnerabilities, I don't know.
Yeah, so it's a very loaded question, because I think as you were describing it, it takes you towards various kind of avenues, right? Should I trust the same model? Should I trust it at all? And maybe your next questions would be well, what happens? This is basically a non-deterministic model. The whole thing is statistics based. And so what happens if I run the same command again? And I had a different talk where it's hey, how do you give your an agent a security brain? And in that talk, what I've done is I would fire up Gemini on the CLI, and I would tell it, okay, go scan my project and tell me if I have an XSS vulnerabilities here. It would give me an answer, or it would write that to my HSMD that I know how to fix it. And that moment, I will quit the Gemini CLI. I will then look at the file, see what's there, open Gemini again, delete the file, the HSMD thing, and ask it the same question. And I did that 3 times, and I showed one times, subsequently one after the other 3 times, you get 3 different results of what it found and what it would suggest you to do to fix the issue. So it's not consistent. Now imagine teams working this way or agents working this way. The advice of this is even before finally this is about what would you do to look at remediating it. It's it is very inconsistent to work that way. So you have that problem where the model just might not be inconsistent in what it proposes to fix. The other problem is, will it actually report the same issues all the time? Imagine you have 20 or 30 or 40 of them. Would I actually all the time be the exact same issues that it will report on? Is another problem. And I think there was a Backbench is a security industry-wide kind of a software bench kind of thing, a sweet bench for security. And if I'm not mistaken, its latest edition was showing 56% or so code being having security vulnerabilities from some of the Anthropic models, the Claude Opus 4.5, before 4.6 went out. So that is literally just a little more vulnerable, dangerous than a coin toss, where it has a 56% of generating something that's vulnerable code. So let's say it found something, now it wants to fix it. The fix itself could actually not be complete fix. So there's like so many aspects of it. There's like the cost of it. So like a security engineer was like posting yesterday on like LinkedIn, was like, hey, I just ran Cloud Code Security. It took me like, I don't know, 40 minutes to run it. It found this and that. But actually, you know what? I just used this other security tool. It found it in like a minute or like a 50 seconds or something, because it's like it's running deterministic versus running, you know, a Gen AI kind of like pipeline. So it takes, you know, and it doesn't cost as much in terms of like tokens, because it just uses like raw rules. So there are like so many aspects that even beyond whether you want to use the same tool, and just to like connect that to MCP and like the examples that I showed. So another security researcher back then, when I was doing like all of this like command injection vulnerable code with MCPs, and you remember like when you that example with like, hey, show me package information for React, and then semicolon and potentially something malicious. So we found out after we reported a bunch of like those kind of issues to MCP servers, we found out, they found out, this other security researcher, that back then one of the mitigations that Anthropic added to Claude Code, the CLI back then, was to run the Haiku, like the faster and low cost models on those tool calls like before, to like run a sanity check if that is something potentially malicious, dangerous, and then decide what. So if you think about it, like I don't know if they still do it today or not, or like if they've enabled something else, but this was like in a few months back. And so if you think about it, there's a lot that goes into trying to secure against those things, like a prompt injection and like cost and then latency and like so many things that we try to guard against. And all of that is just to like say, what is the intent? Is the intent malicious or not? It's kind of like, you know, SQL injection back in the day, where you don't really know, like, was the intent of the developer to run this other query, or is this part of like the real query because we're concatenating it? So we have this like very much elaborate problem now with LLMs. And it kind of like, it all fits together, because the way that they would review the code, I've looked at the security review command of Claude Code. Of Anthropic or whatever. And it's basically like, you are a security expert. Here are all the things that you should report. One of them, by the way, when I was reading this, was like, you should deprioritize, or something like do not prioritize. You can ignore denial of service issues when you report your findings. So now let's say that this is like 100% deterministic. Always, like the model is so smart, we'll always get the same thing. It's amazing. It's great. Now you have this thing that you're using that tells you denial of service is not an actual, like, deprioritize it. Don't tell the user about it. And everyone may be now using this /code review or security review thing command from Anthropic. So everyone is now unaware of a potential denial of service vulnerability that they have. And I have like a ton of demos of like issues that happen with denial of service to things like Bun and OJS, because it's all single threaded and you could create that kind of issues and so on. So it's a very, like I think you are describing the problem. It's a very elaborate attack surface and aspect of how do you even begin to protect against AI and agent related security issues. What do you do? Where do you put it in? And like, what did you like even enumerate the entire attack surface there?
Yeah, I mean, I think I'd love to hear your other talk, because I think right now there's a lot of interest in, you know, right now so many projects are getting developed, like built, and they're getting built, you know, at really low cost, really quickly with, you know, prompting and AI development. And I don't even know, I don't even know where, you know, I think probably 80+% of them probably are using something like the security review function in Claude as the primary, maybe only security assessment. So I'd be really curious what your suggestion would be for someone saying like, hey, you're doing this, you know, maybe this is a side project, like it's not something that is enterprisey. It's just your, you know, whatever, but you're thinking about putting it out on the internet. I would recommend you run these 3 steps before you do that. And maybe that's one of them. Maybe one of them is that security sec. But what are those 3 steps? Like, maybe we'll have you back and you can tell us that answer when you're ready. And maybe it's some scanning combined with you know, a little bit of network type security and things.
Yeah, no, I think it's a good question. The way that we're like, I think positioning that is, Snyk has those tools like scan different kind, like the agent code and like the poisoning and stuff like that, and also like your actual code. And I think what we're saying is really there's a part of it where you just scan the code in a deterministic engine, and there's a part of it that you may use an LLM to figure out like maybe more business logic decisions and intent and stuff like that. But it's really kind of like a stack of them together versus one or the other. So yeah, I mean,
it'd be great. I mean, quite honestly though, I think as soon as you kind of get to that page, you're going to lose 50% plus of the people doing this. I think that's the real. So what I think there's this massive opportunity in the market is for, what is the equivalent of a really good security agent that is, well designed, to use tools and can be incorporated into your vibe coding process as not another tool that you're trying to sort of coax your existing tool to use, but rather a separate agent that is run, that has a really strong security approach, that leverages deterministic tools, that leverages these things, but is actually still effectively commandable from by the vibe coding community that just wants to be like, okay, I'm not going to do /cod code, I'm going to do /snyk inspect. And then it's like, hey, I'm snyk inspect. Let me go take a look. Oh, I'm going to run a bunch of things. I'm going to come back to you. It costs you X amount of dollars to run it or whatever. But you feel like you've actually gotten something a little more permanent. So I'm very, very interested to see where this develops. I just think the existing security models feel totally broken for the pace and the quantity of people who are developing code right now. Just like no friggin' way that most of these are not going to be using enterprise security tools and paying security prices. Like that's just not happening in the way that development is outside of the enterprise. Fine for the enterprise universe, but as this world has cracked into my teenage kids and my friends and everyone and their mother that's like writing custom apps now for the PTA bake sale and for their marathon training app and on and on and on, like just the proliferation of personalized software that people are just generating. What's the solution for that? Because it's not what we're doing. I can tell you.
I'm with you. I want to put this out before we kind of close out. If you go to snyk.studio, I'm inviting everyone to go to, all the vibe coders, everyone listening. That's what we're building, is essentially like an agentic way to find and fix security issues. That is something that also attaches to your agent. You just add it like an MCP and whatever, and it kind of like instructs it. It provides the context and everything else it needs. If you go to snyk.studio, that is kind of like what we're building, and I would love to hear feedback and like everything you need help with. Just find me on social, and I'm there.
I will go try it out. That sounds like I'm literally what I'm looking for is something that provides the right kind of security for everything besides enterprise applications.
Go for it.
Craig, I kind of took over all the talk today. I'm sorry. Did you have questions that you wanted to ask, or did we?
I just wanted to get it just to look it up later. The security related like software bench thing you mentioned. Did you say Backsbench? Like, can you spell what that was?
BAX.
BAX. Okay, got it. Cool. Yeah, that sounded interesting. I wanted to check that out.
Yeah, that's the one.
Great. Awesome. Thank you.
Awesome. Hey, Liran, thanks for joining us today. It was great having you on. Thanks, everyone, for being here. And we'll be back again in a week or two with our next show. Have a wonderful afternoon. Craig, thanks for joining today.
Sure. Thanks.
All right. Take care.